Electrons are arranged according to the principal energy levels, or also known as principal quantum shells. This is an electronic structure of a carbon atom. In its first shell, there are 2 electrons, and in its second shell, there are 4 electrons. This gives carbon an electronic structure of 2,4. The further away is the principal quantum shell, the more electrons the shell is capable of holding. This is because higher energy levels have more orbitals. For example, shell 1 have only 1 orbital, but shell 2 can have 4 orbitals. Since each orbital can only hold 2 electrons, it's reasonable that these shells can only hold 2 times the maximum orbital it can own. The principal quantum shells are further divided into subshells S, P, D, and F. Each type of subshell is capable of holding different amount of electrons. D shell, for example, can have a maximum of 5 orbitals, with a maximum of 2 electrons in each orbital. Each atom has an electronic configuration. Here are 2 examples of nitrogen and chlorine. Let's take a closer look at this configuration. The number at the left represents the principal quantum number, the letter on the right represents the type of subshell, and the number above the letter represents the number of electrons in the subshell. Here is a simple way of writing the electronic configuration. The period is equivalent to the principal quantum number, the first 2 groups is equivalent to the S shell electrons, and the last 2 groups represent the P shell electrons. When we write the configurations, we go from top to bottom and left to right. Let's practice with nitrogen. The first period has a principal quantum number of 1, and there are 2 electrons, so it will be 1s2. We then go down. In the second energy level, there are 2 electrons in the second S shell, so it will be 2s2. N is located at the 3rd position at the P shell, so it will be 2p3. But note that once we get into transition elements, the pattern changes a bit. We'll talk about that in another video. Next, we will learn about the shape of the subshell orbitals. Note that the orbitals are 3-dimensional, and that it is only an area where the electrons are very likely to be found. It is still possible for electrons not to be found inside the shape. This is an s orbital, and it has a spherical shape. This is a p orbital. It looks more like an hourglass with 2 lobes. Note that there are 3 types of p orbitals, and regardless of having the same shape, the axial center of the orbitals can be on both the x, y, and z axis. This diagram is a p orbital along the x-axis. The d orbital has a similar shape to the p orbital, although in addition it has a ring around the center. Another thing you have to learn is writing electronic configuration in a box form. Let's practice with fluorine. First, we write the principal quantum shell and subshells separately. Then, we draw the boxes out according to the maximum orbitals the subshell can hold. Then, we fill in arrows that represent the electrons. In shells with multiple orbitals, we aim to fill in all the empty boxes first. Electrons only pair up if there are no empty orbitals left. And lastly, we fill in the remaining electrons. Thank you for watching this video. Stay tuned in the channel for more A-level chemistry videos.